This question, we have a graph, so we'll start right out with our Oizerga. The origin, that is 0, 0. Y-axis is force. Goes by ones are the numbers, but the increment is by 0.2. X-axis, we have, looks like length in meters, and that the large numbers are 1, so that would be 5, and this goes by 0.1. The intercepts, yes, we have a 0, 0. The y-intercept is 0, 0. And then later we have an x-intercept at 6. Things we could read then are force and distance. The slope is delta F over delta X, which is newtons per meter, which looks like the spring constant K. It has the same units of it anyway. And the area is F times delta X, which has units of Newton meters, which is the units of work. Reading the question, net force. So it's a net force. That's important because that's not the label. So it's the net force. So in this case, if we have a net force, that brings into our minds Newton's second law. So there will be acceleration, which means a change in velocity, which means there will be a change in momentum, and it means there will be a change in kinetic energy. Acts on a body varies with the distance that it has traveled. After traveling 6 meters, we look for 6 meters and we see that 6 meters is over here. So that means from a distance of 0 to 6 meters. The change in kinetic energy. Oh, the change in kinetic energy is the work. That's the definition of the work energy theorem. So what we're looking for in that case is the area. And that's the area of a triangle, which is 1/2 base times height. The base in this case is x. And the height is 10, which is the max force. And so we have the max force over 2 times x. And so that is 10 over 2 times 6. 60 over 2 is 30, so 30 joules. Clearly, if there's a net force, the change in kinetic energy cannot be 0. We can rule that one out. And mathematically, it comes out to 30 joules.